Here's all of the terms that you need to be familiar with for the first test, and this is a really handy resource when you're taking the test. If you run across a word that you're not sure what it means, I'm going to go through this right now. Let's see if I can do it without making any mistakes and match all of these words up with their terms. There's 33 of them, so I'm going to go through it pretty fast. Molecule that has a fluorine, chlorine, or bromine, that's going to be an alkyl halide. That's number one. I'm probably going to skip around a little bit. A molecule that contains a carbon-carbon triple bond, number 17, that is an alkyne. I'm looking for the ones that I feel confident about that are pretty easy. A molecule that contains only carbon and hydrogen atoms in single bonds, that is an alkane. That's number 19. A representation, number 3, a representation that shows all the atoms, all the bonds, all the lone pairs. That's our Lewis structure. Number 3 is Lewis structure. Number 4, when comparing two molecules, this molecule only differs by its shape. That would be, I think, a stereoisomer, but there's a couple different ways that I could have chosen to say that, so I'm gonna save that one. Let's do number 2, a molecule identical to its mirror image. A molecule that's identical to its mirror image, that's achiral. Number 2 is achiral. I'm skipping number 4. Number 5, a molecule that contains a carbon-oxygen double bond that is not located at the end of a carbon chain. That's one of our functional groups, and that is a ketone. Number 6, a ring of carbon atoms without any double or triple bonds is cycloalkane. Oh, that is one of our choices. Number 6, cycloalkane. Number 7, a molecule that contains carbon-oxygen double bond directly adjacent to a nitrogen. That's a functional group. That is the amide functional group. That's number 7 is amide, not amine. 8, a molecule in which at least one carbon atom is bonded to at least 3 carbon atoms. What the heck? I'm skipping that. That looks hard. 9, a carbon atom bonded to 4 different atoms or groups of atoms. That's a chiral carbon, chirality center. Number 9 is chirality center. 10, a molecule that contains a carbon-oxygen double bond at the end of the carbon chain. Only one oxygen is present. That sounds like an aldehyde. Number 10 is aldehyde. Carbon-oxygen double bond located at the end of the chain and only one oxygen is present. When comparing two molecules, this type of molecule has the same number of atoms but differs in the order in which the atoms are connected. That would be our constitutional isomer. Number 11 is a constitutional isomer. 12, medication that provides loss of consciousness is general anesthetic. 12 is a general anesthetic. 13, an oxygen that is single bonded to 2 carbon atoms, that's the ether functional group. 13 is ether, not ester. 14, a molecule that's different from its mirror image, that's a chiral molecule. 14 is chiral. 15, a reaction that converts an alcohol to an alkene, that is dehydration. 16, for reactions that form alkenes, the major product is the product that has the most carbon atoms, the least hydrogen atoms. I honestly don't remember, I don't remember if we even covered that. I'm skipping that for now. A molecule that contains carbon-oxygen double bond directly adjacent to another oxygen. A carbon-oxygen double bond directly adjacent to another oxygen, not at the end of the carbon chain. That is an ester. An ester. 20, an alkene in which 2 matching atoms are on opposite sides of the double bond. That is trans. 21, a reaction in which an alcohol is converted to an aldehyde, ketone, or carboxylic acid. That's the oxidation reaction. 22, shows all atoms but not all bonds. That would be a condensed structure. 22 is condensed structure. 23, does not show carbon or hydrogen or CH bonds. That's our line structure. 24, an alkene in which the matching atoms are on the same side, that is cis, same, they sound the same. 25, a molecule that contains a nitrogen atom that is not bonded to a carbon-oxygen double bond, that is an amine. A molecule that contains a carbon-carbon double bond is an alkene. 26 is alkene. 27, a group of atoms that dictates the molecule's property, that's our functional group. 28, a group of atoms that are attached to the parent chain of the molecule, that would be either substituent or branch. 28, substituent, I see that. 29, a drawing of a chiral molecule that doesn't use wedge dash, that's Fisher projection. 30, when adding HCl or HBr to an alkene, the hydrogen adds to the carbon atoms with the most hydrogens already present. That's Markovnikov's rule. Same for when we're adding water, H2O. 31, the longest continuous chain of carbon atoms, that's our parent chain. 32, a molecule that contains a benzene ring, that would be aromatic. 32 is aromatic. 33, a molecule that contains a carbon-oxygen double bond. Carbon-oxygen double bond directly adjacent to an OH group. That's the carboxylic acid functional group. So let's see what we haven't done. Number 4, back up to the top. Comparing two molecules, this one only differs by shape. We're looking at our choices here. So that's is it enantiomer or is it's stereoisomer? It must be stereoisomer. That's number 4. Number 16, for reactions that form alkenes, the major product is the product that has the most carbon atoms. I don't even see that on the list. This is like huge extra question marks by that. Oh, I skipped 8. Number 8, a molecule in which at least one carbon atom is bonded to at least 3 carbon atoms. Looking at what we have left, that's going to have to be branched alkene. And why do we have, I somehow ended up with some extra words here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. 35 words with, oh, there's more definitions. I gotta scroll down. Genius. 34, a molecule that contains an oxygen bonded to a hydrogen. That is an alcohol. I'm glad that I scrolled down. 35, a molecule that's different from its mirror image. That is the enantiomer. 35. And 36, 6 carbon atoms in a ring with alternating double and single bonds. 6 carbon atoms in a ring with alternating double single bonds. That is benzene. So now we can see what we have left. Saf's rule 16. And honestly, I don't think that I did this. So if you don't see this anywhere in your notes, don't even worry about it because it's not going to be on the test. If it's not in your notes, it will not be on the test.